I guess start with saying thank you for having me here. Being New Hampshire native, it's pretty cool to come back and be able to present up here in Manchester. And thank the panel for coming in to listen and provide some feedback. What I'd like to do is start with just kind of how 206 Ortho became 206 Ortho, then really the patient population we're looking to help, and then a couple questions that we have proposed for the panel and for you guys. And really looking forward to getting some feedback from some people I normally wouldn't have an opportunity to speak with. So 206 Ortho wasn't 206 Ortho when I started, I guess about 3 years ago. It was really just about leaving the company I was with. We'd already been grown, we'd been bought once, about to be bought again, and I said, there's gotta be a better way to help patients get back to full function, their lifestyle back quicker and back to work. So after about a year and a half of looking for really a problem to solve, I decided on basically an orthopedic solution which really resonated with me. And we eventually became 206 Ortho. And then over the last 2 years, we've been building a team to solve that problem. And really the problem is what I call a gap in treatment. And so right now, if you have a bone fracture, a surgeon basically has an option of a cast or a brace, which really leaves you really immobile and strapped, or really an invasive surgery and a metal implant. In a younger active person, the surgeon has a choice. Do I put in a metal implant that I'm going to have to make that patient have a second procedure to remove down the road? And it's fairly invasive. I mean, you're talking about drilling an 11 millimeter, 12 millimeter hole in someone or kind of flaying open their arm. But really the brace side I resonated with, because even though it's minimally invasive, I can speak from experience because when I was 23, just bought a house, had a mortgage, and I was put on in a brace for 12 weeks, and literally, the guy hobbling in crutches, but I was in sales at the time, so you don't make money if you're staying home. So you're not paying your mortgage, but you're getting to the doctor's office, and you're sitting outside batting yourself down from the sweat because you're on crutches and hobbling around. And it's just a miserable 12 weeks. And you really don't change your lifestyle because you basically are active and used to eating a lot, and I can tell you gain a little bit of weight, and you got a leg like a raisin when it comes out, and you get another one twice the size it was. And so, that's really, I guess I was kind of an average Joe because I was past college, but still feeling like I was an athletic person, mountain biking and rock climbing and really trying to stay active. And I'm 35 pounds up, and even at that age, it was hard to lose. Now, we're in a society where people are active later in life. I can only imagine what it's like to lose weight. Well, I can now. It's harder to lose weight 20 years later. But that's the same problem that's there today. And it's also a huge problem with the military. Stress fractures in the military are the number one cost driver for first-year recruits, about 25,000 missed days of work a year. So there's a problem there, and there's really a divide in the middle. When I was working at Pfizer, actually at the time, one of the things that I can tell you is being in sales, it's a really good meter of how productive you are. And I was about 60% of quota. So not only did I gain weight, not only did I have to go through rehab, not only did I have medical costs, but there's a lot of lost productivity with the company. And so that's really what this study looks like. And this study was published last October, which validated what I'd been working on for a year and a half, which was awesome to see. But you get your direct costs, but up to 51% of direct costs are actually your indirect costs, or overall costs. So that's missed work, that's your absenteeism, short-term disability. So there's also another cost that's passing through, and that in today's market is becoming a bigger problem because over 60% of employers self-employ, which means those are real costs. And this is from the day of surgery to 6 months following surgery. And what was nice about this study is they looked at your life 6 months before surgery and backed out all your medical costs from there so they could really see the delta and what the difference was post-injury. And that's really the problem. So it's getting someone back to their lifestyle, but it's also reducing the cost for the employers. And so really what an ideal solution looks like, and from talking with the surgeons, they said you need to develop something that mimics bone, that basically is going to mimic the mechanics of bone and allow basically natural healing. But it's going to need to be minimally invasive because if not, it's like a cast. You're trying to stabilize soft tissue that's swollen around a really rigid structure, and that doesn't work all that well. And then it's got to be resorbable if it's going to be internal fixation, because if not, it's no better than what's there today, because you got to come back and have another surgery, or you got to live with it for a long time and decide if you're ever going to get it out. And so that's what we're doing at 206 Ortho. We're building a team that's around basically developing an injectable, resorbable splint that basically stabilizes long bone fractures. And when we see our advantages, it's really in our proprietary material and bringing people from outside our industry in to develop this material, and taking the team's knowledge of minimally invasive techniques coming from neurosurgery and coming from the catheter world, bringing those techniques over to really a hammer and saw treatment. And then trying to find ways to make sure that we're getting those patients up and rolling faster. And then obviously making sure that it's resorbable. And so when we looked at mechanical properties, what we did was to prove this, we created a finite element analysis. And if you're not aware of what that is, basically we took a scan of a bone and had a guy put it into a computer, and we basically modeled the fracture. And then we modeled a material and said, well, what properties does the material have to have? And so the top line and the bottom line, it's kind of a fine window. Using our technique, what are the properties and where we need to be to basically mimic bone and the bending that bone naturally has to have to heal correctly. And today where we are is we're right in the middle of that zone. We still have a lot of work to go, but what we've shown so far is that we're there, and now it's about tuning the material. And this right here is current materials. So we're about 7 times as stiff as the current resorbable materials that the competitive companies in the market have today. We've done a lot in these 2 years. When we look at what we've accomplished, from my wife and I 3 years ago to where we are today, we actually just hired our first full-time guys this month, so that was a big moment for us. We've done the finite element analysis and the testing I discussed. Last November, I was in Australia. We did our first fracture model to show that we could do our surgical technique, that we could deliver this implant, and that it was safe and allowed the bones to heal. We filed 5 patents during that period of time. We've also looked at our regulatory strategy, and it shows that we have 2 510(k) paths that we can go down. And what we learned in developing this product is we actually have to develop the ideal implant outside the body before we actually inject that material in the body to cure. And so in doing that, there's an opportunity to basically come out with an intermedullary fixation that's better than what they have today because it's resorbable. And then also come out with our in situ or curing in the body version, both through predicate devices. And then we hired Ed Berger with Larchmont Strategic Advisors to do our reimbursement analysis. And in his opinion, we fall within current reimbursement codes. And so if we look at the fracture market, it's really a huge market, right? About 8 million procedures a year. But we're targeting specifically the 65 and under crowd, really that active crowd, that working crowd, and focused on a group that we think we can create value in getting them back to work faster. Now, it doesn't mean from a surgeon's perspective, everybody couldn't benefit from it because it's bone healing, right? But this is really the population where we think we can help them the best. And in looking at that population, we're really focused on some specific bones called long bones or load-bearing bones. So as I said, there's 2 devices. One is as a pre-cured or a hard implant to begin with, and looking at metatarsals and with distal radial fractures with more of a pin, about a 1.5, 2 millimeter pin. And then on large bones, using basically a little 3 millimeter catheter to deliver the implant into the larger bones of basically your upper arm, your forearm, and your leg. And so if we kind of bring everything together and we look at a comparison with the left basically being where your current non-invasive treatments are and the right being your invasive, it really comes down to getting people back to work faster, back to their lifestyle faster, making sure that it's minimally invasive. So basically respecting the tissue around the bone that's already damaged so that the patient can get back on their feet quicker, not take as much medicine, and then really avoiding that secondary procedure. Now, competitors, if you know the orthopedic world, there's a lot of orthopedic companies out there, specifically in trauma. There's a lot of people that make screws and generic screws today. But when you look at really the players, you're probably going to recognize most of these names. These are the real influencers in the market, and also the companies that have the balance sheet that could purchase a company. So rather than have a very busy slide with probably 40, 50 little companies that are up there, these are really the players in the industry that do the most influence. but none of them have what we're doing today. If you remember the slide back where I showed you the 7 gigapascal material, there's about a third the strength of ours. Well, that's what they have. And so from a team, I started with just me and actually Professor Watterson about a year and a half ago. And I'm really proud of the people that have joined the team because we don't have a lot of money. We're raising money. And a couple of them quit other jobs to join us because they believe in what we're doing. And as you can see, come from a lot of great companies. We're also putting together a really good scientific advisor board and board of directors. Don Freeman, who's here today, he's been 30 plus years in med device industry and over 25 boards. He's a great mentor and advisor to me. And so let's look at kind of our path to market. We look at our path to market really first in humans is going to be about a year and a half, 2 years out from today. And first revenue would be out in 2016. A little bit different than a computer company, but we have a fairly clear path to where we're going. And so the top is your small bone and the bottom is our large bone. And so if we just kind of wrap things up and look at where we're at today, this is what we are. We raised a seed round. I funded about $300,000 of it myself, and we got about $250,000 from outside investors. We opened a note to go towards our $2 million A round right now. And it's really taking what we have today, refining that to a commercial product and continuing to build our team. I was asked to ask you guys 2 questions today in the panel specifically, and I think it's a really unique opportunity because we have a physician, we have a venture investor, and we have a former corporate executive who's worked with Medtronic and actually spun out her own company. So I say, who are the influential stakeholders that you'd be talking to? And I say that because in my experience, I've worked with a couple startups. Integra, when we were small, microtherapeutics were purchased, became EV3. EV3 was picked up by Covidien. And I had the opportunity to launch some really disruptive technologies. And there's a leap of faith there. And your typical stakeholders really don't have an interest in always seeing your product come to market because they don't see that right away. And so today's market's really evolving with ambulatory care centers playing a bigger role and insurance companies incentivizing patients not to be treated in hospitals. And so you're seeing a lot of shifting in the markets. It'd be great to get your perspective on who you would go talk to basically make sure that you understand where the market is headed. And then the other one is I brought up basically opportunistic because we have potentially 2 products that we could bring to market versus laser focused on the end product because it's really a dynamic question. It's easy to run the numbers and say this or that, but there's regulatory issues, there's physician issues, proving that a material's safe and compatible with a patient before you bring out the in situ curing version. You've de-risked it on the way, going after non-load bearing bones, if you noticed, before we went after load bearing. So it'd be interesting to get all your perspectives, but I think you could look at things from very different seats. So, thank you.